Yep, there are only 2 examples.
Go.
I feel like there are only 2 examples for like the
Okay.
last 3 days.
Between the loops.
Between the loops.
Yep.
So first of all, write it down.
Between. Wait, that's not between. I wrote the wrong thing. I wrote between curves. These are loops. I like to go into shambles and all.
So we are either going to be talking about 2 curves, an area between, or 1 curve, an area between, like maybe a feature of the curve. So like in this case, we have a loop, correct? We have a loop limit zone. And so I don't really care about the area of the, well, I care about the area between the loops. So let's first of all,
So if I had to do a circle
In red.
and subtract.
it's not a circle. Okay. So 2 plus 4 sine theta means we have 1, 2, 3.
And what is this one called? Is this still a loop?
If it has a loop in it,
What does it mean?
that might be a sign.
What's
Get it
what's
aside.
I feel like there's like a big
So I am looking for the area inside of the limazone
without the loop?
without the loop.
Just screw the loop. You don't. That doesn't work. The loop doesn't work.
Okay. Now let's think about this. Here we would begin. Here's pi. 0. And here's pi over 2. Okay. So if we think about how I would begin to find the area from 0 to 2 pi, I would be finding area like this, right?
You said the bottom with pi.
Even like
No, this is 0,
That's 0.
pi over 2, pi,
yes.
3 pi over 2, pi. So if I find area, this is what I'm going to calculate. And then I would color in my loop. And then, okay, what's the problem?
It takes the loop.
Okay, I colored over the loop, right? So what we're going to need to do,
Subtract out the loop twice.
well, I wouldn't say twice. I would say let's calculate, let's take half of this, and let's calculate the area like this. Then we can subtract out the loop.
How do you do that?
Okay. Let's first of all think about where this loop starts and stops. At your tables, work to find the zeros of this curve so we know where that loop starts and stops. 1, 2, 3,
7
go.
pi over 6, 11 pi over 6,
What he said.
That's just because I had to think about it.
Guys, I gotta say it's 7 pi over 6 to the left. Sorry, that was a little loud. 7 pi over 6 to the left.
Okay, well, since everyone knows the answer now.
She already wrote
Thanks,
it down.
Caleb.
I didn't even get time to figure it out.
Caleb?
So the sine of theta equals negative 1/2 at 7 pi over 6 and 11 pi over 6. Okay. So we need to find, yes,
Is it supposed to be 4, like the maximum height? Or is it supposed to be
and it's
6?
supposed to be 6, but I only counted to 4, didn't I?
Just add a couple
That's how you cheat the system.
No.
All right. In my head, I said it needs to go 6, and then I was looking at 4.
You know what happens to everyone?
All right. So
Adjust.
I think using symmetry is going to really help us. All right. So if I wanted half of the apricot shape,
And just go to pi, right? Some pi or no. Or 3 pi over 2. 7 pi over 6 and 3 pi over 2.
I would say pi over 2 would be a good place to start all the way to
7 pi over 6.
7 pi over 6. Let's do things in order. Okay? So we could take 1/2 the integral from pi over 2 to 7 pi over 6
Times 2.
of r squared, but then we would have to
What area
double it.
is this giving you?
This is giving us
All of that.
that. But we colored over the loop, correct?
Yeah. How are you getting rid? That's what I was wondering. How do you get rid of the loop? You subtract,
We subtract out the loop.
which is from 7 pi over 6 to 3 pi over 2.
If we wanted to double it, yes.
Yeah, double.
Yeah, if we wanted to double it, we could double the integral from 7 pi over 6 to 3 pi over 2. Yes.
Why do you have to double it?
That's only half.
That would be half the loop.
Or half.
The loop goes
Wait,
from...
versus back. Oh yeah, look it up.
Now, if you didn't double it, you could go from 7 pi over 6 to 11 pi over 6, and that would be the same thing.
You have to worry about that.
Yeah. Okay. So do you see... So first of all, give me a little bit of grace as I'm grading your tests, because there's a number of ways that you could set this problem up, right? Yeah, it takes some time to look through, you set it up right, okay? You can use symmetry, you can go for the whole shebang, okay? If you were not going to use symmetry, then you would want to go from negative pi over 6 to 7 pi over 6, and then subtract out the whole from 7 pi over 6 to 11 pi over 6. Okay?
What happened if you did the whole thing?
That's what I just
Oh,
said.
wait, say
Right?
it again. If you did
You
it,
would go from negative pi over 6 to 7 pi over 6, and then subtract out,
well, I mean, what if you went from 0 to pi?
Why would
like 0 to 2 pi,
Yeah, well, or
then you would have,
what happened if one is to cover itself up.
then you would have done the loop twice.
Well, what if you went from 0 to pi?
Then you would not be symmetric at all in this case. This is 0 to pi.
Why would it be negative?
But if you did it to 2 pi, it's twice.
Because you would have to rotate down to get this. Because this is this is 0, so you'd have to rotate backwards to get to here.
How did you know it's pi over 6 then?
Because of the 0.
See, it doesn't end up so bad.
Okay.
It's self-
All right, so this is what I want you to do. Is the antiderivative for this the same as the antiderivative for this? I'm going to give you 3 minutes to work together with your pod to multiply out that binomial, take the antiderivative, shape it.
Will be 16.
The other problems we do, because I'm going to insert one. The other problems we do, we're just going to set up. Okay.
Okay.
You get 4 plus 16 16. That is
Simple cosine squared. Who's like different from cosine?
Yeah, how do you? Yeah.
1/2 minus 1/2. Thank you, Chris. Wait, so 16 is minus.
That's 6, right?
What'd you get for your intake?
Eight.
Chris, do you have any fifth?
I have to plug in 7 pi or
Yeah.
6
I think so, but I think I did it
to that.
I just need to change one number so that you have to have a higher than, but now I got it.
Yeah, what you got? We have multiplied.
Okay, you'll get there. Hold up. X. Where'd you get an X and a theta?
Oh, an X. What am I thinking?
There we go.
No,
It's times 9. It's less than
What'd you get, Chris?
You took a 4 out of it.
Yeah, that's the only reason.
Okay, where? First of all, the easiest thing to do is just keep the 4 in.
Why is that easy?
Because stuff you get once you get down to this part makes it easier.
Why is this so nasty? I don't like this.
That's also 0.
How?
Oh,
How do I plug in 7 pi over 6 into sine 2
it wouldn't just be
Yeah, I
2
was about
sides.
to say
but
So what's
it'd be plus
2
Because
times
that's
7 pi over 6?
7 pi over 3. How do you know what that is?
7 pi over 3 is the coterminal angle
Oh.
of
Yes.
pi over
I know
What?
that.
It's squared.
What? This one?
3. 7 pi over 3
Okay,
is
I
the
would
same pi
still,
over
I wouldn't do that.
Why?
Are you gonna tell me
Yes.
stuff that's wrong?
Yes.
Using
Well,
cosine.
because if I go around
How can you do
2
that?
pi,
Like, don't have a square.
then an extra pi over 3 would be the same answer.
Oh yeah, we have to multiply it again.
So I
Yeah,
can just do like
you
pi
do
over
this,
Oh,
and
wow.
then do the cosine
Yes, you have to
thing.
do half of that.
Okay.
It's
Oh,
still right.
yeah, that's.
Oh, perfect. No, so it turns back to positive triangles.
And we can actually keep that 4 in
I
there.
took the 4.
Yeah, I guess.
No, why is this answer's different?
I
So what
probably
does the
should
final
have taken some
answer come out to be?
Where is it?
12 theta minus 16 cosine theta minus 4 sine 2 theta.
Oh, I got it.
You got it? That's good. I believe in you.
Okay. Do you end up with 12
Theta.
plus 16 cosine in your before the antiderivative
No.
16.
plus sine? That's a sine. Sorry.
Oh, yeah, okay.
Plus 8 sine 2 theta.
Yes.
That was 8 cosine.
Is it
Ah, why do I
is it
keep-
8 plus?
I got 4 plus 16 sine theta plus 16.
Minus.
Should be minus.
I already failed.
Yeah.
That's what I
Oh,
got.
hey, I got to that point.
Okay.
Then the antiderivative.
So that your antiderivative is 12 theta plus 16 cosine theta
Yes.
minus. Right?
Yep.
Okay. minus 4 sine of 2 theta.
I'm talking about.
Okay.
Wait,
All right.
When she
Questions? Questions on why you didn't get what I have up here?
What is the 12 so I think I got everything else.
So this turns into 1/2 minus 1/2 cosine of 2 theta. So 1/2 times 16.
Oh, you have to multiply by 16. Yeah, there's
Okay.
the issue.
All right. So 12 times 7 pi over 2
I'd say
14 times.
plus minus 16 times cosine of 7 pi over 2.
I have 7 pi over 6. Hey, where'd the 2 come from?
That's the problem. Okay. Cosine of 7 pi over 6 times negative 16.
Negative or positive 8.
Radical 3.
Yeah.
Okay.
Wait, never mind. I messed it up then.
Oh yeah, 16 over 2 is 8. Yeah.
Right?
Wait,
Minus
I don't think
4 sine of 7 pi over 3 is 2 radical 3. 7 pi over 3 is just the same as 1 pi over 3. And then when we plug in pi over 2, 6 pi minus 0 minus 0.
Was that
Huh?
it's a lot of work. Okay.
Minus the quantity.
The other one.
How are you gonna do the next problem in 5 minutes?
We're not going to actually do what we're going to say. Okay? When we plug in 3 pi over 2, what's 12 times 3 divided by 2? 18 pi? Minus 0 minus 0, right? Yeah? No.
At the beginning.
No, it's 0, 0.
Yeah, it is.
What's the,
It would just be a copy of that first one.
Yep.
Yeah, it is the other one.
And so we get 4 pi plus 14 radical 3.
Nice.
All right. I don't want to get too hung up on this part of it, okay, because I want to be able to get to another problem. Anthony, do you have a question?
For the radical 3 one, it's 8 plus 8.
Yeah, it should be
So
12
then
radical
minus
3.
2.
Oh, it's 12?
I just assumed that it's
That's a long one.
Huh?
That was a long one.
6 radical 3 plus 6 radical 3 is 12 radical 3.
Oh my goodness.
Whoa, Lord. This never happened on a test. I'm just gonna put no. Just no.
You find one of them and then
But I'll want you to.
The common interior.
Are you going to write it down or just stare at it?
Oh,
I stare at it.
Kind of in awe is what
That looks like a really weird fat
that looks like one of the
butterfly.
things they'd have us color in during kindergarten.
I thought it looks like a
Are
bumblebee.
they not squares? It doesn't look like a circle.
So my projector squishes.
Uh,
So if you look at my computer, it's perfect. Okay?
Wait,
if we are looking at the common interior, then we are looking at this right here.
Yeah. So you just do 4.
Times 4. Yes.
Yeah. This is tricky.
Essentially. However, we need to know what these points are right here. How do we find them?
Set them equal to each other.
Okay, so we have 4 sine of 2 theta equals 2. It's a good thing we practiced this, right? Yep. First day of school. So the sine of 2 theta equals 1/2. Where does the sine equal 1/2?
5/6.
And
5/6. Yes.
so that our theta is pi over 12 and 5 pi over 12. And there would be 6 more, but we don't need to worry about those. But what I want you to notice, when I start to color this, what am I coloring? Which function? Or which curve?
Here,
The flower or the circle?
circle.
The rose curve.
The rose curve. Then I start to do this, right?
Now you're in the circle.
Now I'm doing the circle,
I'm very confused.
and now I'm doing the flower.
So what does that mean? You have to do separate like.
We have to do 3 different things?
Oh.
Unless you split this in half
Multiply by 8.
and multiply by 8.
But this is actually a question we'll have
I'm
to do.
confused.
I'm confused. I'm gonna pay.
Imagine the test.
So
being
what,
one
for that one portion, we would have to take 1/2 the integral from 0 to pi over 12. Because from 0 to pi over 12, we're coloring in the flower.
Okay.
Okay? Oh, that's right. And so, and the flower was,
What?
4 sine of 2 theta.
So that's the.
Then we would have to add in the circle, and from pi over 12 to 5 pi over 12, we're coloring in the circle.
Just 2.
Just 2. I know, that's gonna be a really hard antiderivative, so be careful. Plus, from 5 pi over 12 until pi over 2, we're back to this one.
This is really tricky.
All multiplied by 4.
And it's all multiplied, yeah, by 4.
This is really tricky.
Alright, good setup, guys. Brain break time.
Now, doing the antiderivatives here, better or worse than before?
Better, worse.
Better.
Better.
Better. Much
You
better.
have the antiderivative of 4d theta.
Yeah.
But there's a lot of numbers going on.
Yeah, there's a lot of
Agree.
things
No,
happening.
16 science whole 2.
So symmetry can be your friend if you allow it to be. Okay? Please pay attention to whether the book wants you to take the antiderivative by hand or with a graphing utility.
Default is calculator.
Graphing utility would mean you need to be in radian mode. Okay.
This is always-
Can I clarify anything from this problem for you?
It's like default settings.
Okay?
Why is it 0 to pi over 12?
Because that's where they intersect. Those are those.
You still have to get the first part.
That's kind of.
Okay.
That's kind of cool. The way that works.
Pi over 2, that is right there. Now, if you wanted to do only 2 integrals, you could go 8 times 1/2 from 0 to pi over 12.
Is it when you have to do pi over 4?
Yes. Plus the integral from pi over 12 to pi over 4 of 2 squared d theta.
Interesting. That might be a good.
And pi over 4 would be nice to plug in.
Yeah.
So just things to think about. So the reason why your test isn't for another 5 school days is because we just have some things we really need to work on in terms of getting things set up and how we do our anti-derivatives. Okay? So we're going to take our time and we're going to be patient.
Could you,
Ooh, and Mrs. Holman should probably make copies of things.
could you do it with just like one integral where you just find like the area of parts that aren't like outside the curve and then like take the area of the circle using pi squared divided by 4. And then subtract the parts that are in the square from that.
What did you say?
It's just not lots of that.
Like you can find the area of the circle without having to do a derivative. Like, so could you just like use?
As long as you know what this central angle is right here, which we do, you could find the area of this sector, but you would still need an integral for this piece, which is the same as this piece. But you are right. Technically, we could use the area of a sector.
Well, I'm saying is like since we know that those two pieces outside of that sector are going to be equal, right?
Yeah.
And we could also find the area of the whole circle. And then could we just find the area of one of those tiny sectors and multiply it by 8, and then subtract from the area of the circle using pi r squared?
But then what about these? The circle is going to include these. We don't
Yeah.
want that.
Wouldn't you subtract that if you found the area of
And
those,
you know what this is going to be right here. You can calculate that.
I guess not.
Yeah, that's going to be too tricky.